if a equals to 1, 2, 3 up to n and b is equals to a comma b, then number of surjections from a to b is, that is a into b is. The number of surjection means the number of onto mappings. Here we are talking about only relations, not a functions. So many to one, one onto, one to many are all relations, but one to many is not a function. Here we are talking about only relations. So here the number of surjection, that is number of onto mappings from A to B, we have to tell. So here we can see A is 1 to n, that is number of A here is equals to n, and number of B equals to 2. For number of surjection, we know that if A and B are two non-empty sets, finite sets containing n of A equals to m and n of B equals to n respectively, then number of surjection from A to B will be mcn into n factorial if m is greater than n, where m is number of a number of elements in set A, and n is the number of element in set B. And if it is 0 if m is less than n, that is number of element in set A is less than number of element in set B. But here we have number of A equals to n and number of B equals to 2. It means that number of elements in set A is greater than or equals to number of elements in set B. So we will use first case. Here m is greater than n. So number of surjections will be mcn. Here m is n and n is 2 into n factorial, that is 2 factorial. So but we know that NCR can be written as n factorial upon r factorial into n minus r factorial. So we can write NC2 as n factorial upon 2 factorial into n minus 2 factorial into 2 factorial. Here we can cancel out 2 factorial, 2 factorial. But we know that n factorial can be written as n into n minus 1 into n minus 2 factorial. If we write this n as n into n minus 1 into n minus 2 factorial, then we can see n minus 2 factorial and this n minus 2 factorial in the denominator will get cancelled out. So what we will get? We will get n into n minus 1 only, that is n square minus n. So number of relations from A to B will be n square minus n, that is n into n minus 1. So option here is none of this.